What's up, problem solvers? Welcome to another video. You're really going to like this one, so stick around to the end to see the final answer or give it a go yourself. The question we're going to be tackling in this video is pretty simply stated. Given this diagram, what is the ratio of the blue area to the red area? To put it a bit more formally, ABCD is a square. The line AE is equal to FB, which is equal to a third AB. All of that information was captured in that initial diagram. If you want to give this problem a go yourself, pause the video now. Okay, let's get into the solution. When you first look at this problem, it's tempting to want to find that blue area simply by, finding the area of the triangles. So we have two right triangles there, ADF and AEB. Surely we can just work them out somehow using base times height divided by 2. If you experiment with that a little bit, you find there's overlapping areas and it's hard to figure out how to actually find that blue area in relation to the red area. I eventually got to the point where I wanted to find the ratio of DG to GF and EG to GB. So I wanted to find the point of intersection of those two lines in relation to the rest of the square. To do that, I used vectors. So I labeled AB, vector A, and AD, vector B, and then I found DF or FD in relation to A and B. FD is FA plus AD, FA is negative 2/3 A, AD is B, so FD is going to be B take 2/3 A. EB is EA plus AB, EA is negative 1/3 B, and AB is just A, so EB is going to be A take 1/3 B. Then we can say GB is going to be some fraction of EB, so we can multiply EB by a scale factor, let's call that K, and FG is going to be some fraction of FD, so let's multiply FD by some scale factor, let's say M, and that will give us the vector FG. So K and M are some fraction between 0 and 1, such that they scale those vectors down to GB and FG. Okay, now that we have these two vectors GB and FG, let's now write an expression for the vector FB. FB is going to be FG plus GB. Okay, so from F to B, we could also take the journey from F to G and then G to B. So FB is also equal to K multiplied by A take 1/3 B plus M B take 2/3 A. What else do we know FB is? Looking at the diagram again, they tell us in the question FB is a third AB. So FB is a third of A. Okay, this equation actually allows us to solve for K and M and find the ratio that those two lines are split into. So how can we do this? Well, first note that FB has no B vector, or it's 0B, right? It's just a horizontal line. So the coefficients of B in this equation must sum to 0. So expanding those brackets, we would have K multiplied by negative 1/3, and then plus M, they're the coefficients of B, they must sum to 0. So summing the coefficients, we get negative K on 3 plus M equals 0. Rearranging, multiplied by 3, add K to the other side, we get K equal to 3M. This is nice because now we can write this entire equation representing the vector FB in terms of M. So then we can say it's 3M multiplied by A take 1/3 B plus M multiplied by B take 2/3 A equals 1/3 A. This is going to allow us to solve for M. Okay, so taking this equation, this time looking at the coefficients of A, they are going to have to sum to 1/3. So 3M is the coefficient of the first term for A, and negative 2M on 3 is the coefficient of A for the second term. We get 3M take 2M on 3 equal to 1/3. Multiplied by 3, we get 9M take 2M equals 1. Therefore, M is 1/7. Remember what M was? That was the scale factor of FD to get to FG. Let's find K. Remember K was 3M. That means K is 3 times a 7th. K will equal 3/7. And remember what K was? That was that scale factor to go from EB to GB. This allows us to say that the line DF is split in the ratio DG to GF equals 6 to 1, and EG to GB will be split in the ratio 4 to 3. Again, because GB is 3/7 of EB and FG is 1/7 of FD. Okay, I have the ratio of these lines. We can represent that as x to 6x and 3y to 4y. How is this going to help us find the ratio of the areas? Well, let's continue. I'm going to split this blue area up now into a rectangle and 2 right triangles. Okay, so these are right angle triangles in here. Next, I'm going to label these 2 points P and Q, and I'm going to represent this length QF as 2. Why am I using 2? There's no real reason. I could use any number there, but 2 gives nice whole numbers for the rest of the lengths. Next, remember FG to GD. Those 2 lines are in the ratio 1 to 6. And if we look at these 2 right triangles QGF and PDG, these are similar right triangles, and that linear scale factor is 6. So I can take that length QF, multiply it by 6, and I'll have the base of the larger right triangle, which is also the length AQ. So to get AQ, all I need to do is multiply QF by 6. So AQ will be 12. Next, let's look at the length FB. This is pretty easy, right? Because in the question they tell us the ratio of AF to FB is 2 to 1. So FB is going to be half of AF. Half of 14 is 7. Next, let's look at AP, the other side of that rectangle. What length will this have in relation to the other lengths we've found so far? Here I want you to focus on the 2 right triangles QGB and AEB. And remember that these 2 lines, BG and GE, are in the ratio 3 to 4. Or in other words, the triangle QGB is 3/7 of AEB. That means the length QG is 3/7 of AE. AE we know because they tell us in the question AE is equal to FB. So AE is equal to 7, QG is 3/7 of that, therefore it's 3/7 of 7. What is 3/7 of 7? That's 3. So QG and therefore AP is equal to 3. Then if AE is 7, AP is 3, PE must be 4, and ED, we can read that straight from the other length. ED is told in the question is equal to AF, so that's going to be 14. Now we have broken that blue area up into 2 right triangles and a rectangle. We know all of the dimensions. We can easily find the area. Firstly, focusing on the right triangle I've highlighted in yellow, that area is going to be base times height divided by 2. So 12 times 18 divided by 2, that is 108. The rectangle I've shaded in green. That's just the width times the height, or the width times the length, sorry. 3 times 12 is 36. And the final right triangle I've highlighted in dark blue, that area is going to be base times height. That's 9 times 3 divided by 2. That's 27 on 2. Then we can sum these 3 areas. So 108 plus 36 plus 27 on 2 will give us the total blue area. Adding those 3 areas together, we get 157.5. And we can easily find the area of the entire square. Adding those lengths up, 12 plus 2 plus 7 is 21. So the area of the square is going to be 21 squared, which is 441. Okay, we have the total area of the square. We have the blue area. Now we can work out the ratio of the blue to the red area. Firstly, that blue area, again, we said was 157.5. The red area is going to be the total area, take that blue area, 441 take 157.5, that's 283.5. So the ratio of the blue area to the red area is 157.5 to 283.5, which simplifies to 5 to 9. Isn't that nice? I thought that was really nice to get that as a final solution. But what did you think of that problem? Did you give it a go? Did you maybe find an easier solution? Let me know in the comments. Leave a like if you appreciated this video. Subscribe if you want to see more content, and I'll see you in the next one. Bye for now.